In this podcast, I'm going to talk about z-scores. Z-scores measures distance of raw scores from the mean. Its unit of measure is in standard deviations. Z-scores is equal to 0 at the mean. Z-scores are negative to the left of the mean. Z-scores are positive to the right of the mean. So we have a bell curve, and right in the middle is the mean. To the right is positive z-scores. To the left is negative z-scores. So let's imagine we have an observation that's one standard deviation away from the mean. If we wanted to know what is the probability of an observation being between 0 and 1 standard deviation away from the mean, you'd look that up in the back of your book. And the value there should be 34%. Now, if you remember, the bell curve is symmetrical. So the area from 0 to negative 1 standard deviation away from the mean is also 34%. If you look at the area between negative 1 and 1 standard deviation away, it's 68%. Now a common z-score is 1.96, and that means that 47.5% of the observations will fall between 0 and 1.96 standard deviations away from the mean. Again, it's symmetrical, 47.5% from 0 to negative 1.96, which would give us 47.5% on both sides. There's 95% chance that any observation will be between a negative 1.96 and positive 1.96. Now, what's interesting is if 95% of the observations are between 1.96 and negative 1.96, that means that 5% of the observations have to be in those yellow tails. And we get that by saying 5% plus 95% is equal to 100%. So basically 95% in the middle plus those two yellow tails is 100% of everything. We have 5% total in those two tails. If we take that 5% and cut it in half to determine how much is in each tail, obviously it's 2.5% is in each tail. So 2.5% is to the left or less than 1.96, negative 1.96. There's 95% in the middle, and there's 2.5% chance that an observation will be greater than 1.96 standard deviations away from the mean. And that will just about do it for this podcast.